Okay. Okay, no problem. Thank you. Okay, allow me to start this course. Actually, this course, the principal material already been discussed. Yeah, last week. Yeah, last week, and as I promised that this week we will hands on what we have learned for linear regressions. Yes. Okay. I just make a summary about this PowerPoint. Yeah, actually reminding me and all of us that the learning objective of this topic is how to use regression analysis to to predict the value of a dependent variable based on an independent variables. The meaning of the regression coefficient B0 and B1, or in other reference also we use as a beta 0 and beta 1. And then how to evaluate the assumption of the regression analysis and know what to do if the assumptions are violated. Yeah. To make inference about the slope and correlations coefficient, actually in this case to test whether our slope is quite acceptable in certain standard, particularly in certain significant level. And then the last is to estimate the mean value and predict individual values. Okay, let's start. This is the definition correlation versus regression. Actually, we have learned yesterday about the correlation and the regression. Actually, when we regress, when we make regressions in terms of linear regression, there is always a correlation between y-axis and x-axis. Okay, we just move forward, and in this slide, we just show that differences between linear and nonlinear. In other words, is curve linear, for example, here. And you can see the linearity from this point and this point could be positive or negative correlations. Okay, and this is showing between strong relationship and weak relationship. You can see based on the spread of the data. Yeah, the spread of the data. You can see here that a strong correlation the data is really tied to the line yeah. So the here the gap is not so big compared to this one. Happen in both type of correlations. Yeah, either positive or negative. Okay. And this is also we can take from the residual graph. Yeah, actually the residual, and then you can see here also this is can be evident for knowing between this one is kind of no correlation between x and y. Even the data is spread big, or the data is not spread quite big. Even the data is tied to the line here, for example, the predictor. But since you can see here, as x increase, the y is doesn't affect anything to the y data. So we can say this is no relationship, or there is no correlations. And you can see here, finally, maybe using the Excel, you can create this kind of formula. This is the intercept, this is the slope, and the model also we can assume there is a yeah, error as linear combinations. The error is random, and the error is normal, is normally distributed. Okay, and you can see here after we plot, or we can draw the predictor, the red line here, you can analyze which the location of each component. I mean, the meaning of the beta 0, the meaning of beta 1, and the location of the error. You can see here, this is the beta 0, and this is the slope. You can see it's just comparison, how to say, comparison or between x and y. And then the error is located, is a gap between the observed value or observed sample to the estimated, yeah, estimated line, yeah, to the predictor, yeah. Okay, I hope there is no, yeah, no question about this. And then, okay, let's move forward to the this kind of the sample data. You can see here, for example, this is a host price in this data in times with $1,000, and we will put this data for y-axis, and this is the square feet, the size of the host, yeah, and this is maybe in term in feet, yeah, no matter, uh, and it will be put on the x-axis. Okay, and then first we want to plot the data, something like this, yeah, plot the data being two-dimensional data. And in this case, the y-axis here is the price, yeah, the price, house price, and the x-axis here, the size of the house. And you can see the data is spread in this area. So also we can, I think you have no problem to show this data. So if you can see here, my Excel here, I already put it here, put in here, yeah. You can see my Excel, yeah, no problem.
Yes, sir. We
Okay,
can see
good.
it.
Yeah, and then you plot this one actually before we maybe put the trend line. Is the data is similar to the PowerPoint, and then if you put the trend line, for example, and you put the, how to say, maybe more option, and you can see display the equation chart, and then you can see here the predictor, the for this data. Okay, and then what happened, uh okay, and what happened then, using regression using tools, yeah, in this case we want to compute regression using Excel. Okay, this you can see in my PDF. You can see this is the layout, the output, Excel output for computing the regressions. Also, we will conduct in this Excel. Uh, this is my Excel, and then you can choose the data here. The data, you can see data, and then you click the data analysis. The data analysis, yeah, maybe some of you, your Excel, maybe you can check by yourself to those using computer, and you can open your Excel, and maybe you realize that you don't have this kind of tools, data analysis. I'm not sure that you already install this, because in the default Excel there is no data analysis. But don't worry, you can install it free, yeah, as an add-in. You can see, you can open the file. Let me you can open the file, and then options, and then option, and then you can click the add-in, and then you can see the analysis tool pack, yeah, and then okay, and then okay, and then after that, in this toolbar will come out, will appear the data analysis uh, button, yeah, okay, and then you can click this one, and there are many analysis tools, but in this case, in this topic, we will use regression. So just select the regression, and okay, and you can input the range here, this one, and for this one is this one. For the y-axis, the host price, and for the x-axis is square size or square meter. In this case, is for the size of the house. Okay, and you can click the label, or yeah, it's just optional. And also you can check, change the confidence level, but I will let be default being 95%, and then uh okay, okay, you got this one, you got this output. If we compare to this one, it will be same, yeah, same what we have compute using the Excel. You can see here this is regression statistics and R square, adjusted R, and so on and so on. Yeah, and you can uh, notice particularly for this point. Yeah, it's similar. Yeah, this point you can see here the intercept is 98 0.24, and this is 0.1. And if you look at back to this graph, you remember this one, it's similar. Yeah, it's not similar, this is precisely same. Yeah, the y, this is the beta 1, and 98.24, this is the beta 0. Okay, you can see here, yeah, this point you can take this value as beta 1 and beta 0. Okay, and then ah this is the another way to explain in terms of graphical representations based on this data, and then you can create the linear, yeah, the straight line in the predictor, which has slope being 0.1 and the intercept 9.8. Yeah, okay, and then this is we already still, and then also this is for the slope. This is, for example, we can predict or we can estimate if you have house the size being 2000 square feet, and then what is the price will be, what will be the price, yeah, For example, yeah, we can substitute being 2000 into these equations to the predictor here, and then 2000 multiplied by 0.1 and plus 98, and then you got this result, the 100. The estimated price will be 317.85 times $1,000, something like that. That's kind of prediction, yeah, using this linear regressions. Okay, and then in this predictor, based on this graphical representation, you can see here the predictor is only valid around this relevant range. You can see the relevant range is where the data come out and when the data ends or finish. Otherwise, the data before, yeah, you can see here the red dash line before the uh, black line here, and the red dash line after the range. Uh, that's beyond the data or outside the data. So we cannot guarantee in this topic, we cannot suggest to make extrapolations, yeah, extrapolation, or in this case is uh, we 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 cannot predict, we cannot suggest, we cannot make a prediction about the data. In this case, for example, if we have 3,000 square feet, what price then? We cannot use because the observed data is located on the relevant lens. But you can see here, for example, in 3,000 square feet, we don't have enough data. So in this case, we cannot use the predictor. Okay? Okay. Okay, next. There is a variation. There is an error. What is the difference between the variation in an error? Yeah, usually in the sample data, the variation, it's we can say that this is kind of error. So you can see in this linear regression there is three type of error. You can see here sum, total sum of square, and then regression sum of square, error sum of square. Actually, like last week we already discussed this. If you remember this graphical representation here, you can see here, yeah, I hope you remember this one. For example, we have the predictor, the blue line. Yeah, this is the predictors, and then we have the average of y, the red line, the average of y data. Okay, and then we take a sample here, uh, the blue dot here, and you can easily identify as the SST is respect to the error from the real data to the average of y. The SSA is the error uh, between the observed data, the sample data, to the predictor. And the SSR is the error between the predictor respect to the average of y. So the error between the data to the average of y is just we can decompose, yeah, we can decompose as SSA and SSR. Yeah, you can see sum up between SSA and SSR. Okay, we can compute this SST, SSA, and SSR for all the sample data. Yeah, okay. So We move forward to the coefficient of determinations. R square, yeah, R square, and then we denote as R power by 2, and then we can compute by SSR divided by SST, regression of sum of square and total sum of square. And this coefficient determination, in other words, we can say as a correlations. You remember correlations, since this you can no, 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 no. No correlation. Yeah. No, no, no. No correlation. Coefficient determination is just R square, and then the value is between 0 and 1. Okay. And then you can see here the coefficient of determination is representing the, how to say, relationship, yeah, relationship between x and y, means that in very simple definitions, the determination of, yeah, coefficient of determination is uh, representing relationship between x and y. So the condition will be a relationship, there is a relationship, and there is no relationship, something like this. Okay, and the value of coefficient determination between, yeah, 0 and 1. Condition of 1 when the data is perfectly uh, in the prediction line. Otherwise, as the decreasing, for example, going to be 0, means that the data become spread. Yeah, spread. Yeah, you can see here. Okay, and when the 0, the data become no correlation. Okay, where is the coefficient of determination? There is, yeah, this is, yeah. Where is the in the Excel? This one. Okay, okay. So we can get this one, and you can compute or you can check uh, using the still in the Excel. You can see here. This one is divided by this one. So this one is SSR, and this one is SST. Yeah. Okay. So the result is 0.5. Okay. And then this is if you use mathematical expressions for computing the standard of standard error of estimate. Yeah, you can see here. This is the SSA divided by n minus 2. The n is number of the n is sample size. And this is the standard error. You can see here standard error being 41, and you can check from the Excel also similar 41. So, and this observation, maybe you can check, this is the total observation is 10. Okay. Comparing standard error, yeah, you can see small standard error means that the data is tightened to the predictor, and otherwise the large standard error means the data is spread. Yeah, refer to the stride the predictor. Yeah. Okay. This is the another assumption that you can use in regression. For example, linearity, independence error, normality of error, and equal variance or homoscedasticity. The probability of the error has constant variance. Okay, talking the error, you will arrive at this residual analysis. You can see from the from this formula that the residual, or we can say error, is a gap or between the data itself and the predictor. Yeah, and the predictor you can see here, and then the residual will be like this. Yeah, will be like this. This is the best residual. This one. This one, the best residual means that the residual will be horizontal line. Why horizontal line? You remember that the A is Y. This is the observed data, and this is the estimated. Yeah, estimated. Yeah, and the result will be like this, and the data will be scattered respect to the horizontal line. Please remember, we are talking about the residual analysis. Residual, yeah, is already different with the estimated. How to say? With the predictor, yeah. The line here is not the predictor. Residual line. Okay. You can see here. This is a pattern that we have independent residual, or we have an independent error. Since the data is spread something like this, not like this or not like this. Okay. This kind of residual data you can, for example, we have the data here, the given the predicted house price, and then we have the residual being like this, and you can see here for example, yeah, for example, there is minus 6 is around here. Mm, for example, the highest one, minus 49. Yeah, it's similar for this data. So this is what this data. The highest one, the positive highest. This is for this data. You can see here, this is 60 on, and this is this around 64. Yeah, this is the residual data. Okay, so far, is there any comment or any questions, please?
So, sir, this graph is plotting the residual, right? Not
Yes,
the prediction.
yes. Is there any problem to plotting the residual?
I think no, sir.
No, okay. Okay, if there is no problem, and then we can move forward. This is kind of auto correlations. Yeah, no problem. And then Okay. Okay, so
Sir, I have questions, sir. I forgot to
yes,
ask.
please.
For the residual graph, what is the x-axis here for this one? Oh, the square feet. Okay.
Yeah, square feet, yes.
Okay, sir.
Hmm. Actually, in this slide, what we then learn is testing the correlations, autocorrelation in the residual, but it's not so matter. So in this case, we'll jump to the this one. So in this case, we want to compute the inference about the slope. What thing or what matters that why we should make an inference about the slope? Yeah. As you remember, that the slope is telling us, is telling us how strong, you can see how strong, how the x and y being or having, not being, having a relationship. In bahasa, allow me to explain in bahasa. Slope ini itu kan memberitahu kita seberapa besar perubahan data X terhadap Y gitu kan. Misalkan X-nya berubah 1 kali, Y-nya ini berubahnya berapa kali gitu kan. Slope itu. Slope is telling us how the data is changing, respect to the X variable. Nah, and then kemudian kita ingin ngetes, loh kok ngetes? Why we need to test this slope? Yeah, we need to test the slope. You remember that the slope is beta 1. And beta 1 is a random variable. And because of random variable, there is a probability, right? Probability. How to firm that the slope is how to say, is in bahasa ya, how firm, seberapa meyakinkan bahwa slope ini gitu loh, nilai ini seberapa yakin gitu loh, seberapa yakin. Maka untuk mengetesnya, misalkan kita bisa mengetes berdasarkan significant level 95% dengan tingkat kepercayaannya 90%, 95%, atau dengan kata lain dengan tingkat error 5%, begitu kan. Kita punya keyakinan 95% bahwa B1 itu benar. Oke. Saya ulangi, jadi kenapa kita perlu mengetes slope? Wah, kita mengetes slope kan hasilnya kan ya segitu-gitu aja, Pak. Misalkan kan kalau dari grafiknya di sini Y prediktornya adalah 98,24 ditambah 0,1 kali X kan. Nah, kita sudah sepakat bahwa ini beta 0, ini beta 1, bahwa keduanya ini merupakan random variable. Random variable berarti kan nilai ini bisa salah atau ya bisa keliru kan karena random begitu ya. Karena random variabel maka di sana ada tingkat kepercayaan, tingkat kepercayaan. Kepercayaan dalam bahasa matematisnya di sana ada probabilitas, ada kemungkinan, probabilitas ya. There is a probability ya. And then untuk meyakinkan karena ini probabilitas kita harus ngetes dong, harus mengetes. Testing, do test ya, do test. And do test using hypothesis testing. Ya. Oke. Until this point, is there any question how we should test, how then we arrive at hypothesis testing? Is there any questions? No? Or confused?
Nothing for now, no, sir.
No, yeah, okay, good. Okay, so we have a reason, yeah? We have a reason why we conduct the test. And then first we compute the standard error. A standard error means the variance of beta 1. This is the variance of beta 1 actually. This is the variance of beta 1. The variance of beta 1. So we have a SB1. And then you can see here, as we have a smaller variance, mean that the possible line will be, yeah, something like this. Compared to the large SB1, you can see the possible predictor will be, yeah, you can see here more, how to say, more, lebih variatif lah begitu ya ini. Possibility-nya itu lebih variatif. Dia bisa slope-nya bisa ya seperti itulah. Bisa sangat ekstrim terhadap prediktornya. Berbeda kalau yang small SB1, the prediktornya itu tidak akan ekstrim sekali gitu kan. Relatively tight to the predictor. Okay. Okay. And then we can, once we arrive at the hypothesis testing, and then we state what is the null hypothesis and what is the alternate hypothesis. And you can see here, for example, the null hypothesis that means that the beta 1 become 0. And then for alternate hypothesis, beta 1 is not 0. Beta 1 being 0 means that there is no linear relationships Otherwise, when the beta 1 not 0, there is a linear relationship, yeah, or linear relationship does exist. Okay, and then what kind of test that we can use? T distribution or T statistic, yeah, and then you can use this formula, and this is the regression slope, and this is the hypothesis slope here, and then this is degree of freedom, yeah, and SB1 is standard error of the slope, yeah, this is the standard error of the slope. Okay, and then we arrive at this test, and then uh, you can see here, this is the beta 1 and this is SB1, and then you can see the result of the t test. You can see from this point. Actually, we can pick up from this value here. So you can see the head tables. T test means that the test for the distribution t. This is for the slope. This is the intercept. And you can see for the slope, we have 3.3. 3.3, yeah, 3.3 for the t value. So if we check to the distribution of t with the 95, yeah, 95 significant level, 95 this significant level, and you got this critical value for both sides, and you get this one, the critical value is minus 2.3 for the left side, and the right side 2.3, and located 3.3, yeah, after we got the t value is located here. Located here means that, yeah, means that we recheck, yeah, we recheck null hypothesis. You remember that null hypothesis that assume that the beta 1 is 0, means that from this test that the beta 1 is not 0. So the conclusion is there is a sufficient evidence that square footage, yeah, the square size affect to the house price. Okay, is there any questions? You got it? You got it?
So why should we set the H0 for beta equal to 0? And why not H0 is beta not equal to 0? And yeah.
Yeah, no problem, no problem. For example, you change this statement, right? For example, the H0 become the beta 1, not 0, something like this, kan? And H1 equal to beta 1 equal to 0. Okay?
Yes, sir.
Yes. Okay. And then if we back to this one. So in the test, in the test, so if we use this one, so we want to test, yeah, in this case, test the H1. So we still using this formula, and we submitted uh, the beta 0 here, 0. beta 1 becomes 0, and then the beta 1 actually it's come from the predictor, and this is the standard error, yeah, from the standard, and then you can get this one stem number. Okay.
Okay, sir.
Okay, and then uh means that, but in this so I need to, in this graph, so we rewrite the null hypothesis is beta 1 equal to 0. Not 0, yeah. Beta 1 equal to 0. So in this case, we recheck we recheck this. Don't recheck. You got it or no? And then since the 3.3 is located here, so we recheck H1. H1 means that this one. So we accept, we still have, we still arrive at the same conclusions. But in this case is reject one. You got it or still have a questions?
Yes, I got it, sir. Thank you.
Mm-hmm. Maybe I will show you a bit about maybe you can see here actually this t-test actually testing for, yeah, from this slide, yeah, from this slide, this t-test testing for H0 or H1, I'm asking.
Is it testing for H0?
H0, why not
Uh,
H1?
because for the B1 in the equation, we insert 0.
Okay, good. Okay, that's the point. Okay, very good. I hope the other is have same reason with with you. Okay, that's kind of how we test a variable in regression, linear regression. Particularly, we are testing the slope variable. Okay, and there is another test. This is a p-value test. You can see here the p-value. You can see from the Excel also we get this one, and the p-value is 0.01. Usually the p-value represent the how the error will be, how will be the error come out. So in this case, a 0.01 means that only 1%. If you use, yeah, if you use 95 significant level, and so this is only 1% possible error. So in this case, so we will arrive in this. It's mean that we reject the H0. We are reject the H0. So in this case, there is a sufficient evidence that square fetch affect the host price. This is the another test, and then fortunately we arrive at the same conclusions. Maybe some of you asking, Pak, apakah akan selalu seperti itu? Apakah p-value akan selalu agree dengan t-test? Tidak selalu. It's not always, ya. There is no always that the t-test and the p-value test will be have a same arrive at the same conclusion. There is not always. It's depend on the data actually. Yeah. Yeah. You can check based on the data. Okay. This is the F test actually for uh, uh, yeah, you can see here for the F test from the Excel, you can see it's similar. Yeah, actually. The significant level of for F test, you can see here this one also. Okay. So we have a result here that for 95 significant level of for F test, you can see the critical value being 5.32. Yeah. And we arrive at the F test or F value being 11. So the location is here. Location is here means that we reject the beta 1. Okay. And then also for confidence interval, yeah, interval with 95%, yeah. You can see here. Yeah, it's similar, yeah. Okay. Okay, you can see here. What does it mean? Yeah, what does it mean? Yeah, for the t value. So, is there any? Oh, there is no graph. So I will make a sketch for you. So in this case, for the t distribution, okay, for 95%, so this is 95%. So in this case, 2.5%, and this is 2.5%. So what is the critical value here? For the slope here is this one, yeah, this one and this one, 0.03374, and for the right side is 0.18580. So something like this. With the degree of freedom 9 being n minus 2. In this case, the data is 10 minus 2 is 8. Okay, I have no problem. Yeah, that's. And then another test is testing correlation coefficient. Testing correlation coefficient. In this case, we state the hypothesis testing being like this. For example, the null hypothesis is correlation coefficient is 0. And then for the alternate hypothesis, correlation coefficient being not 0. And then you can arrive at the t test. You can use the same way, and we arrive at there is a evident linear association that the 5% level of confidence. You can see here 3.3, and the level of confidence here, the critical value is 2.3, and the 3.3 is outside. Yeah, so we reject the null hypothesis. Okay, this is the estimating mean value and the prediction individual value. So estimating mean value is we can use the depend on the data means value from the y or the mean value from the predictor. You can see here you can choose or you can test the mean value, yeah, using hypothesis testing as well. Okay, that's all my presentation today. Is there any questions? I hope you can hands-on by yourself using Excel. Yeah, and maybe yes, maybe tomorrow I will give. We can make an exercise using data, and then you can compute using Excel several parameter and also how to test the predictor as well. Either be for the slope or even intercept, something like this. Okay, is there any questions?
Sir,
Yeah.
could you please share the PPT where there's like to make for example, like to make an exponential graph into linear regressions using
Oh,
LEN, something like
oh
that.
yeah, yeah. You mean the PPT for last week, right?
Uh, yeah, last week. Yeah, last
Yes,
week, I
yes,
guess.
yes. Of course, of
Yes.
course. Sure, sure. Yeah. I'm sorry because I'm not uploaded several material that I have presented last week or previous meeting.
Okay, sir. Thank you.
Okay. Is there any questions? Other questions? No. If no, yeah. Please check it. Please check a mass regularly, and then because I will post it either for the recorded video or the PowerPoint. Yes. Okay. Thank you very much for your attention and stay healthy and stay protocol kesehatan and see you tomorrow. Thank you very much. See you next week. Next week.